to talk today about the fundamental counting principles, just counting principles in general. We're going to talk a little bit about permutations and combinations, different formulas, where order matters, where it doesn't. But these next two sections, after this is probability. These next two sections, guys, you really have to pay attention to wording. It's not that the math computation behind it is extremely difficult. It's just the wording. You've got to be really paying attention to what the question is telling you and what it's asking. So this is the type test where you guys are going to want to ask me, do you mean this or that? That's what I'm testing you on. So you're going to have to really pay attention, and we're going to practice this a bunch. But when we talk about counting principles, I mean, you guys can read, but it says that this is just an introduction to the basic counting principles. And what that means is just basically figuring out how many ways something can happen. You know, how many phone numbers are possible? You guys can't write out all the different possibilities that there could be. There's a mathematical way to figure these things out. So if you look at this first question, right? Question 1 and 2 are extremely similar. This is just introducing you to these kinds of problems and thinking. So let's look at the two problems. We'll discuss them independently and then together, independently of each other, and then as looking at them as one different problem. So it says 8 pieces of paper are numbered 1 to 8 and placed in a box. So visualize that. You have 8 Post-its, and there's 1, 2, 3, 4, 5, 6, 7, 8 written on it. You put it in a box. 1 piece of paper is drawn from the box. So look at me. I take the paper out. I look at it, see what number it is. And then what does it say happens? The piece goes back into the box. It's returned to the box. Why is that important information? You could draw it again. So what happens when I have 8 pieces of paper, I take one out, and then I put it back in. How many are in the box still? 8. Okay? Understand, we're going to talk about things that have with replacement, means you put it back, or without replacement. Like I took out one piece, I looked at it, and then I put it in my pocket. So if I was going to draw again, how many are left in the box? 7. Okay, so that kind of a wording. Another thing that's important to understand is it says that 1 piece of paper was drawn, and then it's put back. Then it says the second piece of paper is drawn, and its number is written down. So when we draw the papers, each time I'm drawing a paper, how many papers am I taking out? Each time I put my hand in the box, how many papers do I take out? 1. Okay, so 1 at a time. So it says the number is written down. Finally, the two numbers are added together. How many different ways can the sum be obtained be a 12? So let's think about this. Right, on my first draw, the first time I put my hand in and I grab out, I could get a 1, a 2, a 3, a 4, a 5, a 6, a 7, or an 8, correct? Now I put all of the papers back in, so that means the second time I draw, what are my options? A 1, a 2, God bless you, a 3, a 4, a 5, a 6, a 7, and an 8. Agreed? Okay, so let's think about all the combinations that could give me 12 when I add it together. Starting on the top. If I grab out a 1, can I add anything to it that's going to give me 12? No. Okay, so that's not going to help us. What about a 2? No. 3? No. 4. If I grab a 4 on my first draw, what would I have to get on the second draw to get a 12? Okay, so 4 plus 8, you guys, equals 12, yeah? Okay. What about if I pulled out a 5 on my first draw? I'd have to get a 7 the second time, all right? So 5 plus 7 is 12, all right? What about if I pulled a 6? I'd have to get a 6, so 6 plus 6 is 12, all right? What about if I pulled out a 7? A 5, okay. And then what about if I pulled out an 8? So if I pulled out an 8, I could get a 4. Are there any other combinations that I could generate here? Like, do you guys agree if I pulled out an 8 on my first draw, I'd have to get a 4 on the second draw? That's accounted for here. If I pulled a 7 on my second draw, and I got a 5 on the first draw, that's accounted there, right? You guys agree with me? Yes. So there's 5 different possibilities. Okay, cool. Now, this same question is right here, but there's a little bit of a difference. It says 8 pieces of paper are numbered from 1 to 8, placed in a box. What's the difference here? 2 pieces of paper are drawn at the same time. I still want to get 12. Why is that important information, that 2 pieces are drawn at the same time? Jeremy?
Because you can't pick the same one.
Correct. If I pull a 4 and an 8, isn't that the same thing as the 8 and the 4? All right, so one of these wouldn't count in my second, in this, the way that the second thing is worded. What about if I pulled out a 5 and a 7? Well, isn't that the same thing as pulling out a 7 and a 5? So then that one wouldn't work, right? Because those are this, you're doubling up. It's the same thing. What's another combination that couldn't work? Why can't the 6 and 6 work? Because there's only one 6. So in the case, in our second example, how many different ways can we get the sum of 12 if we pull 2 cards at the same time? 2 different ways. Do you guys see how that was the exact same problem? The gist of it was the same. The elements were the same. You're still trying to get 12. You're still adding. But the thing that changed was how you drew the cards. Does everyone see the difference there? Right? That is what you're going to be playing with a little bit here. Semantics. You're going to be trying to figure out, okay, what are they telling me in these directions? The math behind it, everybody in here can say 4 plus 8 and 8 plus 4 is 12. You got to figure out what they're talking about. The difference between counting problems in example 1 and 2 can be decided by saying the random selection occurs with replacement and the other one is without replacement. What they mean by that, you're going to have a million problems that say, I have a bag of marbles, right? I have 8 marbles in the bag. I reach in and I grab out a blue one. And the next thing will say, what are the probability, what's the chances of getting the next one if I had replacement? What does that mean? I took the marble out, I looked at it, what did I do with it? Before I drew my next one, what did I do with that marble if there is replacement? I put it back in the bag. If you have something and you take your marble out and you look at it and it's without replacement, you put it in your pocket. The next time you reach your hand in the bag, how many marbles are there if there was 8 to begin with? There's only 7. So think about that, guys. The way that that changes things is, say the probability of, and we'll talk about this a little more, but the probability of grabbing something, marbles, 4 out of 8 the first time you grab, 4 blue out of 8 total. With replacement means the next time I put my hand in the bag, say I'm trying to get red, say there's 3 red. If I put that blue one back, there's still how many marbles in the bag? 8. If you don't have replacement, okay, I have those 4 blue that I could possibly get. If I took that marble that I pulled out and I put it in my pocket, what are the chances of me getting a red one? It's 3 out of how much? 7. Do you see the difference mathematically? If you're going to multiply those 2 fractions together, or in a case we were talking about adding, the answers would be different. So with replacement, I should have done it in pink. With replacement, what happens to the denominator? Stays the same. Without replacement, what happens? It changes. It's going to decrease. Does that make sense? Just something to think about for the next few days. Something to think about. And again, a lot of this is going to seem like, what? We're going to spend a few days on it. We're going to practice these problems. That can be confusing, I know. All right, examples 1 and 2 describe simple counting problems, which you can list the possible ways that an event occurs. Right? What are the possibilities if I flip a coin? What are the 2 outcomes that I could possibly get? Heads or tails? That's easy to list out, right? If I have 10 things, what's the possibility that I pick 1 of the 10? 1 out of 10, right? There's only 10. It's easy to kind of figure out, but some events occur in so many different ways that it's not feasible to write the entire list. You just can't physically write them all down. So that's when we talk about the fundamental counting principle. It says, let event 1 and event 2, let E1 and E2 be events. First event can occur multiple different ways. Second event can occur multiple different ways. The number of ways the 2 events occur is when it's the product, we multiply them. All right, so we're going to be multiplying numbers together. We're going to get real big numbers in a hurry, and that's okay. There could be several events happening, and we're just multiplying them all together. Now, we're going to come across some things that are supposed to be common knowledge. If you guys look at modules, I put a deck of cards, like a picture of a deck of cards. I was amazed how many people have never seen a deck of cards. There's 52 cards in a deck. Anybody know what the cards are that have the faces on them called? Face cards. Okay. How many red are there? 26. There. How many black? 26. How many different suits are there? 4. Okay. Does anybody know what they are? Oh. Okay. You guys know a little more than other people did. That's good. Because you're going to be at a lot of probability questions, guys, is based on a deck of cards. You need to know that. That's called common knowledge. You should know those things. Just like a question like this. It says, how many different pairs of letters from the English alphabet are possible? Well, we need to know, first thing, how many letters are in the alphabet? My girls know. They learned it in kindergarten. How many? 26. I usually get 25 to 27. There's like a range. Notice they said the English alphabet. I know Spanish has a few extras in there. So there's 26 letters. That is important to know. All right, what does the word pair mean? 2. Okay. So pair means 2. Now, some of you are like, oh, can't I just write them all down? Sure. Let's start over here. Okay, I can get an A and an A. I could get an A and a B. I could get an A and a C. I could get an A and a D. How long would this take us? Quite some time, yeah? Because once we get through with all the A's, then we have to do what? And then we got to do. And then we have to do. So let's think about it for a second. How many different things are we talking about? How many letters are in this pair? There's 2. So I'm going to put myself 2 spaces. And our fundamental counting principle tells us to do what to our letters? What did it say to do up here? We're going to multiply. So I'm going to put a multiply over here. So in this first space, guys, think about a bag, right? There's a bag of letters. How many letters are in that bag? If I reach my hand in, how many different letters are in that bag? 26. All right, I look at the letter, put it back in. We just assume it's there, again, because it doesn't say it's not. So the second time I reach my hand in there, and I pull out and try to pair it together, how many are there? 26. So when you multiply those 2 numbers together, what is 26 times 26? How much? 676. There's 676 different pairs of letters that you could put together in the English alphabet. Now, how could I change that problem? I could say, all right, how many different pairs? And no letter can be repeated. So if there's 26 different for the first one, how many would be left for the second one? 25, because something couldn't be repeated. So you just have to pay attention to the wording. Right? You'll see a lot of these questions you'll see on your web assignment. We'll talk about phone numbers, and they'll talk about ATM pins. Again, common knowledge that we need to be aware of. It says a telephone number in the United States have 10 digits. What is a digit? It's a number. Okay, what are the digits? 0 through 9. How many numbers are there in 0 through 9? There's 10. Okay, that's important to know. All right, this says the first 3. Okay, so I have a phone number. Right, you guys all have a phone number with an area code? Okay, here's my area code. They want to know how many different local telephone numbers can be within one area code. So it's all the same area code. It's all 305. It's all 954. It's all 786. You don't have to worry about that. But read what they tell you. It says how many different telephone numbers are possible within this area code. Did they give me any restrictions? Did they say, hey, you can't use something? It says note what? At this time, a local telephone number cannot begin with what? 0 or 1. So this first number, they're telling you, cannot be a 0 or a 1. Of all the digits that we know we have, there's 10. 0 and 1 cannot be used just for that first space. So how many possibilities are there for that first space? 8. Does it tell you anything about the other ones? No. So this second number could be anything, 0 through 9. Could be anything, 0 through 9, anything, anything, anything. And what do we do with the fundamental counting principle? We multiply. So this would be 8 and 6 zeros. 1, 2, 3, 4. Whoops, did I not put enough spaces? Right? 1, 2, 3, 4, 5, 6. Yeah. 6 zeros. So how many different phone numbers can we have for the 954? Given this stipulation, that has to begin with a 2 or higher. 8 million. Right, could you physically sit here and write them all down? No. Right, does that make sense? Okay. Scooting along. Again, you'll have something, maybe, I'll talk, like, just say I said there was a 4-digit ATM pin. So 4-digit, what do I think? How many digits are there for each possibility? But the last one has to be even. So it would be 10, 10, 10, and what? How many of the digits are even? Count them, 0, 2, 4, 6, and 8. How many are even? So there's 5 possibilities. So that's how you guys, it'll be a pin, it'll be a phone number, those sorts of things. Now we're going to talk about specific things. On your calculator, I can show you where the calculator does this for you, but I'm going to need to see the work anyway, so it's just a shortcut. But we're going to talk about the difference between a permutation and a combination. There's a PRB button on your calculator, you'll see it. But this is a permutation, and this is a combination. You'll have an N and an R. I'll show you the formula here in a second. Some problems you'll use the formula, some of them you just use your brain. N is always bigger than R, always, always, always. But a permutation, this is what's really important, order matters. In a combination, it doesn't matter. Now, what I mean by that, you guys will have just basic problems given to you that says NPR, N choose R, whatever. Or you'll have some that say 3 people are running a race. Now, if you have to decide if order matters or not, however many of you want to say it doesn't matter if you win or lose. If I'm running in a race, I care if I come in first, second, or third, correct? Order matters in a case when you're running a race. If you're running for an elected position like president, vice president, something like that, where you have specific jobs. Order doesn't matter in a situation where you're elected to a committee. Say Miss Lovett needs help with the pep rally club. And she's going to choose 5 of you to be in the pep rally club. Does it matter if Cassie is chosen before Connor? No, because they're all doing the same job. So when there's a specific job or a specific title, we'll say given, first, second, third, that's where order matters. If you're all doing the same thing, you're on a committee, you're all planning homecoming, you're putting toppings on a sandwich. It doesn't matter what goes first, if mayonnaise goes before mustard, that doesn't matter. What matters is if something has an order. Like think about if you go to the movies, right? You and 5 friends go to the movies. Does it matter who sits in the first seat or can everyone sit in the first seat? Only one, right? So if I have a line and I'm like, okay, 5 people are going to sit, what are the possibilities for someone to sit in the first seat? There's 5. Well, then how many people are left to sit down in the second seat? 4, then what? 3, then what? Then what? If you're arranging books, when you put books on a shelf, can you put every single book in the exact same spot? No, order matters. So that's where you guys are going to distinguish between the two. All right, how many permutations of the following letters are possible? I'm going to show you the formula here in a second. But think about this. These are the letters we're talking about. These specific letters we're putting in order. How many of them are there? Okay, so in this first spot, what letter could go there? A, B, C, D, or E, correct? Or F. So there's 6 possibilities. So once one of them is put there, can I put that same number? No, I have to take one of them away. So now how many are left over? 5. Then how many? 4. Then how many? Then how many? Then how many? And what do we do to this? We multiply them all together. What does that look like, guys? 6 factorial. Good. Permutations are just factorial problems. What is 6 factorial? What's 6 times 5 times 4 times 3 times 2 times 1? Anybody? Come on. 6 times 5 times 4 times 3 times 2 times 1. 720. Thank you. There's 720 ways. All right. Okay. Throwing a lot at you at one time. I understand that. All right, so let's think about, does order matter or not in this case? I got a word problem. I have 8 horses and they're running in a race. How many different ways can these horses come in first, second, or third? Does it matter? Yeah, of course it matters. How many horses are in this race? 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 horses in this race. If I wanted to know how many different ways they all could place, it would just be 8 factorial. 8 times 7 times 6 times 7. But I'm not worried about every single place. I'm only worried about first, second, and third, correct? So of these 8 horses, what's the possibility that one of them could come in first? How many different horses are there? There's 8, okay? Well, once that first horse comes in first, then there's only how many left over for second place? 7. Then how many left over for third? 6, and so forth. Now, if they wanted to know how many different ways could they all place, it would just be 8 times 7 times 6 times, but they're not looking for that. They're just looking for the first 3. So you multiply those together. How many different ways can these horses come in first, second, and third place? Is it 336? 336 ways. But do you guys understand why? Oh, it's not 8, 8, 8, 8, because it matters. Once somebody comes in first, there can be no other first place person. Once somebody comes in second, there's no other second place, or horse. Sorry, I thought we were talking about people. Scooting along. Here is the formula for a permutation. Now, a lot of times, it's easier to just work through it like we just did, writing it out with the spaces. But sometimes you'll be given a problem that just says like this, 8p3. And what this is saying is there's 8 horses, and we want to know how many different places they come in. There's 3 places, right, first, second, third? But order matters here. That's why you're using a permutation. There's a combination formula that I'll show you in a second. And this is where you have to say, oh, does order matter or not? The formula is n factorial over n minus r factorial. The first number is always n. The second number is always r. Think about it alphabetically. What comes first, n or r? The bigger number will always be first, or else mathematically it won't work out. But when you plug this in, this is 8 factorial over 8 minus 3 factorial. And again, there's buttons on your calculator. I'll show you tomorrow. So this is 8 times 7 times 6 times 5. Why did I stop at 5 factorial? Because 8 minus 3 is 5. I can go right here, cross that out, and then, guys, 8 times 7 times 6 is 336, which is what we just figured out, right? Okay. Now, again, WebAssign is going to give you some of these just straight out. That's what that's saying. Use the P formula. Yeah.
I know this isn't the actual scenario, but let's say that was like 12 minus 4 on the bottom, and you have 8 factorial over 8 factorial. What would you do?
1.
1.
Mm-hmm. Well, here's a little fun fact. What do you think 0 factorial is? It's 1. What's anything to 0 power? 1. Yep. Fun fact. That was probably going to come up tomorrow. Okay. Now you're like, oh, okay, I'm kind of getting the hang of this. All right, let's throw a wrench in it. Distinguishable. It's a very important word right there. You will see this 95% of the time with words. I want you to write this out. When you see distinguishable, I want you to remember to divide out repeats. You'll see what I mean in just 1 second. You're going to divide out repeats. Now, how this works. How many distinguishable ways can the letters banana be arranged? Well, how many letters are there? 6, right? Banana. So, just like our other letter problems, we said, okay, well, there's 6 possibilities here. Well, once I write down that first one, then how many are left? 5. Then how many? 4, then 3, then 2, then 1. And you guys would say, oh, just multiply them all together. But what do you notice about the word banana? It has repeating letters. So if you just left it like that, you'd be counting some of the same things twice. So whenever you have a word and it says, what are the distinguishable permutations? It's the total number of letters factorial divided by the repeated letter factorial. Meaning, there's 6 letters, right? So it's 6 factorial over. What repeats? A. All right, how many times does A repeat? 1, 2, 3. Okay, A repeats 3, so it's 3 factorial. What other letter repeats? N. How many times? So 2 factorial. Does that just all cancel out? No, guys. 3 factorial times 2 factorial is not 6. If you need to write it all out, write it all out. 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 and 2 times 1, correct? If that helps you see and you don't want to stop at the different factorial top bottom, fine. So my 1s will cancel here, 2s. I have a 3 that cancels with a 3. Can I cancel anything with that 2 on the bottom? Yeah, I don't have to. I can just multiply it together. But I could say 2 goes into 4 twice, right? So I have 6 times 5 times 2, which is 60. So there's 60 ways that I could get different combinations. That's a lot more than 6 factorial. So anytime, you guys will see this with the word Mississippi, football, occurrence, anything that has repeated letters, all that's saying is, okay, take whatever the total is factorial and then divide out anything, however many times the thing repeats. Does that make sense? All right, now we're going to talk about combinations. This is when order doesn't matter. They're telling you, you have a deck of cards, the dealer's going to give you this. It doesn't matter what the order is. Doesn't matter how you line up. If you're playing Uno, guys, right? You get your deck of cards, your pack of cards. How many of you line them up if you play Uno? You put them in order, color, all that? I'm trying to teach my girls to do that. It's like random. It just drives me nuts. But I put them in number order or turn them all the right way. But you don't have to. So if you have a combination, this is the combination formula. You'll have something on WebAssign that says like 5C2. This is obviously not a permutation. It's a combination. Why is it a combination? Because there's a big C in the middle. This formula is very similar, but notice there's a little extra in the denominator. So you would say 5 factorial. Then you would say 5 minus 2 factorial times 2 factorial. And that's how you would set it up. Again, I will show you in your calculator how you can just plug this in if you want to. And then you would just figure it out. But I need to see at least this so you understand which formula you're using if you're going to use the formula or not. So here's some combination questions. And some of you are like, well, how do I know the difference? Well, what did I tell you? What's the big thing? What's the big difference between a combination and a permutation? In combination, order doesn't matter. So if they tell you order doesn't matter, then you know, oh, I'm using a combination, not a permutation. So how many different ways can 3 letters be chosen from the letters A, B, C, D, and E? So you're like, okay, do I use the combination formula or the permutation formula? What did they tell you that is super important? The order of the letters is what? Not important. That means I'm using a combination. Tells you to choose 3 from how many? 5, right? So where does the 5 go? Where does the 3 go? Which number goes first? Always, guys. The bigger. So 5 is going to go here, and 3 is going to go here. So in order to figure this out, you have 5 factorial. Is this the same example I just did? Oh. It's like I just randomly put something up. So I have 5 minus 3 factorial, and then 3 factorial, right? You guys with me? If you need to do this, say this is n, this is r. So I have 5 factorial over 2 factorial times 3 factorial. Now, somebody, first period, like, it just confuses me when you stop with the, don't stop then, write everything out if it makes you feel better. So on the numerator, I have 5, 4, 3, 2. Do I really have to write the ones? No, I'm not going to. So on the bottom, I have 2 times 3 times 2, right? So what cancels out? 2's, 3, What else? 2 goes into 2 once. 2 goes into 4 how many times? Twice. So how many combinations do I have? I have 10. And again, I'll show you in your calculator how you can just do this. You don't need to write it all out. But I do need to see at least this. So I know that you guys know which formula to use. All right, look at the next one. Standard poker, 5 cards from a deck of 52. How many different poker hands are possible? After the cards are dealt, the player may reorder them. So order is not important. Is this the combination or a permutation? Combination. So I'm going to put a big C right here. And I have 52 cards, and the dealer's giving out 5. So what numbers go where? Say it again. 52 is first, and 5 is second. So it's 52 factorial over 52 minus 5 factorial times 5 factorial. So this is going to be a bigger one. So on top, I have 52 factorial. On the bottom, what's 52 minus 5? 47 times 5. All right, so if we were going to work all this out, write it all out, you have 52 times 51 times 50 times 49 times 48 times 47. Now, could I keep going? Yes. Do I want to? No, that's why I'm going to stop right there, because I have a 47 factorial on the bottom. And then I also have 5 times 4 times 3 times 2. So my 47s cancel. Now I can go ahead and multiply the top. You're fine. Divide the bottom, but I'm going to go ahead and cross cancel just to make my numbers a little smaller. So 5 goes into 50. How many times? 10 times. All right. 3 goes into 48. How many times? 16. And then 2 goes into 16. How many times? 8. Does 4 go? Yep, 4 goes into what? 52? How many times? 13. Now, if you canceled and did different numbers, that's fine. We'll still get the same answer. When I do a lot of canceling out like that, I like to rewrite everything just to make sure I don't miss anything. I have a 13, a 51, a 10, a 49, and an 8. All right, somebody multiply that for me. 13 times 51 times 10 times 9. Just kidding. 13, 51, 10, 49, and 8. $2,598,960. Now, honestly, guys, I know you probably don't sit home and think about this. Did you really think that out of a deck of 52 cards, when you hand out somebody 5 cards, there's 2,598,960 different ways you could order those cards, or that you could get? Like, that's a lot. It's kind of neat, a little bit. On WebAssign, you're gonna have questions, and it's gonna be this big long word problem, and it says 17 people are picked to be on a committee. There's 2 people on a committee. Is that a permutation or a combination if you're picked to be on a committee? Combination, good. What about if 7 jurors are picked to be on a jury? Combination. Does it matter who gets picked? No, you just don't want to be that one. Knock on wood, I don't want jury duty. But just understand, that's what I want you guys to work on. When they talk about lining up, when they talk about sitting in a row or sitting at the movies, that's when order does matter. Because think about it, can you all sit on the same seat? No. So open up your WebAssign.